Hello, there's Brandon.
Good
Hello,
morning.
good morning. All right, there's Brittany. Good morning. Colin, good morning. Nasrin, good morning. Xavier, good morning. I really appreciate the high percentage of video in the class. And it's not just a percent. Particularly appreciate the actual individuals who, I appreciate everybody. Don't get me wrong, but I'm really feeling like I'm getting to know individuals in this class. So I appreciate it. Okay. Uh, which includes but is not restricted to Brandon, Brittany, Colin, Nasser, and Xavier. Okay, see, that's a tricky line to walk. All right, I'm letting everybody in. Oh, and Alexis. All right. And everybody, obviously. All right, so wait, I'm saying hello. Oh, wait. So hello to those of you I just said hello to, and good morning, Chanel, and good morning, Charlene, and good morning, Anissa. And actually, yes, you see, I really do appreciate the video, but I'm really realizing as I'm looking in the chat that this class, there are people that really make use of the chat, and I really feel like I know them as well. Really. So thank you. Anyway, I don't know why I'm getting all sentimental already. Good morning, Brittany, and good morning, Adenelsi, and good morning, Gaia, and good morning, Nasrin, and good morning, Emily, and good morning, Carolina, and good morning, Alexis. All right. Who else did I not? Okay. Oh my God, Carolina, that is here I am trying to get all sentimental, and that is intense. Okay. And by intense, I mean I'm totally freaked out. Bless, thank you. Well, bless you too. Oh, I get it. Yes, thank you. Um, okay. Hold on. Just get and I believe, good morning. Got it. All right. Thank you, camera person commuting. Got it. Totally appreciated. And I'm not trying to, no, totally totally understood. Uh, why is it okay. So we're gonna start my and again, okay, what am I trying to say? You can look out for my impression is, no, we have class tomorrow, right? We right at normal time. And I think that's tricky for all of us, including me. But unless I I'm I mean, I assume that that's the case. Okay. Um, But that's right, right? Like tomorrow is Wednesday. Did I just? Yes, thank you, Brittany. Okay, right. It's sometimes, and honestly, I've said this before. Sometimes I just can't make that work because other things are happening, and like I have a hospital schedule that doesn't care about Chandra. But but 99%, we're making it work tomorrow. Just small percentage. Just look out for notifications from me or spread the word. If I will send you a notification if I, but I think we're fine. Okay, all right. Yeah, I believe yes, direct chat person. I'm setting a mixed signal here. I apologize. Yes, my belief is that we are having normal class tomorrow at this time tomorrow. Certainly, if you don't hear from me, we are. Yes, there's a 1% chance that like at midnight or something, I'm going to send you a notification. Which is, but if you don't hear a notification from me, then we are on tomorrow. And yes, I believe I'll even check one more time right now. Hold on a second. But yes, sorry. And I don't mean to send mixed signals. I just, uh, yes, we're on tomorrow. Yes. But I appreciate direct chat person, how you call it normal people class. Yeah, well, I don't know about normal people, and I don't even know about normal class, but yes, we're having class tomorrow. Okay. So let's get rolling back to physics. Yesterday I made a big point about Galileo's principle of relativity. Again, believe me, Galileo's principle of relativity underlies the whole class and all of physics, and it'll keep coming up sometimes explicitly. Like there's going to be more forms of it. Wait, we did do the other two. Yeah. Believe me, there will be more forms and they will get more mathematical. It won't always just seem like English talking. Like it will get more directly mathematical, the forms of Galileo's principle of relativity. Um, and you'll see more and more how it directly applies to problem solving. But the big message for the moment is even when it doesn't seem like it's there, or when you're solving problems, if you're solving problems and you're doing fine, then you're doing fine. But if you're ever stuck, particularly on step three, like what is the concept that I need to do, or like how should I set this up, or what am I missing? When in doubt, where you want your brain to start going is to this idea that every constant velocity is a relation between two objects, not a property of one object, right? Like that's like the overall idea. And what that and see, I'm gonna go off again. What that really means in terms of problem solving, okay, what it really means often in terms of problem solving is that you always have to, you always can, but you always have to choose your perspective, your coordinate system, your frame of reference before you even start solving. Like you have to decide, am I watching this problem? Am I taking measurements from the perspective of the earth or of the sun, or more concretely, like from object A, or am I watching it from the perspective of object B, right? And even more concretely, even although I said this quickly yesterday, even more concretely, when you start off a problem, like you label a coordinate system, you say, I'm choosing to look at it this way, and I'm choosing that that direction is positive and that direction is negative, et cetera, et cetera. The key to physics really is knowing that there's all these choices to be made before we even take measurements or analyze. The amazing breakthrough of physics is that we can make these choices. Like really, like we can choose to look at the universe from the perspective of Earth or from the perspective of sun or whatever, right? And the breakthrough is like, oh my God, either perspective works and neither perspective is more correct than the other. Like that's the crazy breakthrough. But the flip side, well, and furthermore, that therefore we can make a choice that will make things more convenient for us. We can choose to solve problems and look at them from a perspective that, in fact, reduces mathematical headaches or opens up insights, whatever. We can choose perspectives that are more convenient for us. Honestly, again, that is actually the breakthrough of physics, or a breakthrough of physics. But the flip side that takes people a while to get used to is that we have to choose, therefore, that you can't just solve problems like in a vacuum or in space. That every time you do an analysis in physics, you actually have to first be conscious of the choice. Like that, even if you don't think you're making a choice, you tacitly are. You're always looking at something from some kind of perspective. So in physics, you have to know what that perspective is before you begin and declare it to yourself in the world, and then stick with that choice as you proceed through the problem, right? So that's the thing. We can choose our perspective, but we must choose a perspective. There's no abstaining. Okay, so that's like the lesson, and that just like and it tends to end up being the most important in physics in the places where we forget to consciously think about it. Okay, so now I'm going to go back to the homework now. So I'm going to do math, get back to math and problem solving for a while. And the other thing is now we're going to get back to this whole topic of acceleration. And you might be like, what's that have to do with anything? Like what I thought we were talking about velocities. Now we're talking about acceleration. But please do remember that we now move to acceleration because acceleration is not that way. Acceleration gets us closer to, if you want to say, objective truths. I mean, closer to, in the sense that accelerations you feel, right? I mean, when the airplane is taking off or landing or turning or slowing down or blah, 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 when the airplane is changing its velocity, oh, then you feel it. Then if you stand up to go to the bathroom, you're like, you have to adjust and all this kind of stuff, right? Accelerations are not just a matter of perspective, the way velocities are. So we're not saying everything is just anarchy, right? We're saying velocity is far more up for grabs than we might have ever realized. But acceleration is not. So we're now into the realm of talking about acceleration. Okay. Okay, I'm looking at the chat. Okay. So hence back to the homework. I'm going to do a screen share to remind us where we are in the homework. Sorry. Um, oh, Yeah, okay. Um, all right, I'm gonna go. Okay, so we're here, I believe. I mean, uh, why am I pausing? I'm pausing. Hang on one second. I'm gonna get, one second. Um, oh, there's something in the chat. I'm sorry. Getting my head together, but wow. Oh my God, this class is funny. Okay. Wow. Yes, that was more than one second. Okay, did not see that coming. Put that in the that was risky. Put that in the submit that for points. Someone just pointed out. I said I'll be back in a second or whatever, and someone just pointed out it was more than 1 second. Like, whoa, yowza. Okay. But I'll take it. No, no, I know it was a joke. No, no, I know. It was just a risky joke. No, it was funny. You can tell because my voice is going like this. Okay. What I want to quickly and what again, if I haven't made this, no, err on that side, all y'all. Like erring on this, saying stuff is better than not saying stuff. I mean, like, yeah, even risk, like, really. Okay, I'm going to shut up. But it's always bet. See what happens if you guys don't talk. I'm just going to talk myself into some crazy rabbit hole, right? You need to keep your job is to keep this ship heading in a not insane direction. Um, so yes, good. Okay, I'm doing one quick calculation, um, so that I can give you answers. Hold on one second. Oh, oh yeah. Okay, okay, okay. I just want to quickly say that for can I zoom? I see there's something in the chat. I'm actually going to ignore for just for a small interval of time. Um, um, for this one at the bottom, 3B. Tell me if I'm wrong. You tell me in the chat. I will look in the chat in a second. Like, I don't want to rabbit. I know if I start writing this one down, I could get all caught up. I believe the answer to 3B, if you're looking at the board right now, I believe the answer is like 8.33, approximately 8.33 times 10 to the negative third, to the negative 3 um miles. No, I'm lying. I'm lying. Hold on one second. That's a lie. Yeah, yeah, yeah. I'm sorry. I believe, I'm just saying this because I'm afraid I'm going to get all caught up. I believe the answer to 3B is 1.39. Obviously, there's digits, so but 1.39 times 10 to the negative fourth miles per second squared. Miles per second squared. Miles per second per second. Um, I don't know why they left it in miles rather than meters, but they did. Um, so I'm going to look in the chat in a second. I'm going to say it one more time. I believe the answer is 1.39 times 10 to the negative fourth. miles per second squared. First of all, I'm going to look in the chat and see if you agree or disagree. Awesome. Oh, you can leave it. Oh, great, great, great. I love this class. I love this class. Hold on. Oh, and there's like real questions in the chat. Okay. So, okay, one thing at a time. First of all, um, first of all, you seem to agree with the answer. Good. Thank you. Like, yes, you could express it different ways. You could express it as 1 over 7,200. That is totally fine. You could express it as 0.0001388. Totally fine. I mean, I think, scientific notation is like good in science, but yeah, yeah, yeah. I agree with all those answers, and I'm psyched that you got it. And thank you for like participating and showing and doing the homework. And you should all submit for points, all of you, and multiplayer co-op. Okay. And you did cook it, yes. Um, so wait, before I go on to anything else, let me say a couple quick things about that. Because I know many of us still need help with unit conversion and things like that. I'm making the choice that I don't want to like spend the whole class on it right now. But first of all, if you have any insecurity at all or discomfort about you, I mean, let me back up. This is a unit conversion problem, right? Like what it's getting at in B. It is what you're supposed to do in B is just a unit conversion. I don't mean that's easy, but I'm saying that's like the whole issue. The physics, and I'll address that in a moment. But the physics takeaway is that ultimately accelerations have 2 units of time in the denominator, right? Like first, I think it's easier to picture that with 2 different units of time in the denominator. Like when a car's accelerate, like on car commercials, they don't say the new Honda CRV has an acceleration. Like they don't say the new Honda goes from 0 to 60. Like that's not an advertisement. All cars go from 0 to 60 at some point. Like any car can go from 0 miles per hour to 60 miles per hour. What they say is that the car can go from 0 to 60 in 1.4 seconds or like whatever, right? What they're trying to tell you about acceleration, they're saying it takes a very little amount of time for this thing to get up to a high speed. So acceleration is a change in distance per time. So there's always 2 units of time referenced in an acceleration. But it could be like miles per hour per minute or whatever. But then we realize as physicists, it's just cleaner and easier and more consistent and more workable if we arrange it so that the units, so if we do a unit conversion so that the units are the same, like miles per second, or more customarily, like meters per second. And what everybody needs to say, I know you've seen this in high school, most of you, but just to be okay. So when we say meters per second, and we put both of the seconds in the denominator, if they're both in the denominator, which like they totally are, they're both being treated as independent variables. Then once you say seconds and seconds in the denominator, they're both being multiplied. So you could say seconds squared, as you said in high school, right? Your accelerations tend to be measured in meters per second squared. I just want to emphasize 2 things before I go on. Like number one, we're not doing something psychedelic. I mean, there's enough weirdness in physics later on where we can do weird things with time and space stuff, but we are not being Michael J. Fox with a flux capacitor here. We're not squaring time. We're just literally saying there's 2 references to time. Okay, that's number one. And so then when you do the unit conversion, I think what most of you know is that there's 60 seconds in a minute and 60 minutes in an hour. So somehow in here, the number 60 is going to have to be involved 3 times. Twice because we're going from, seconds because we're going from because we're going from hours to seconds. So hours to minutes to seconds. That's 60 and 60. And then another time because we're going from minutes to seconds. So in effect, we're either dividing or multiplying by 63 times, right? Right? Well, I mean, I have my own trick for knowing whether to multiply or divide, which I think is usually the issue for most students. Like, am I multiplying or dividing? And it usually confuses students or people. It gets even more confusing when the thing that you're converting is in the denominator. Like that really throws people off for good reason. So on the one hand, if you got this wrong and you still don't see why, or like you don't like, feel free to text me or email and ask me for a quick tutorial on unit conversions. I will not be ashamed of you. I mean, don't be ashamed of yourself. Okay, like I'm happy to walk through it with you, and I have my own trick that might help you, even if you've tried it a million times in chemistry and never got it right. Like honestly. But the other thing is, as a physicist, there is a trick or like a technique for doing this right. But as a physicist, what we really honestly do is we just stand back and look at the problem and we go, okay, there's 60s involved. There's three 60s involved. I either have to multiply or divide, like I can't remember which. I could set it all up and do stoichiometry, or I could go, wait a minute, let me just think about it. Like a second is a lot smaller than an hour, right? If the number I got in part A is like 30 miles per hour, if it's going 30, if every minute it's increasing its speed by 30 miles per hour, if I just stand back, the English is asking me, okay, how many miles per hour will it increase by every second rather than every minute? Well, a second's a lot smaller. So it's going to gain a lot less in that time. It just doesn't have time to gain that much in a second as it did in a minute. So the number's got to get smaller. And then similarly, I thought I was looking at how many miles per hour it's gaining, but now it's just asking how many miles per second it's gaining. Well, that's a lot. That's got to be a lot smaller. Do you see what so I just say to myself, oh my God, the number I'm looking for has got to be a lot smaller than the number 30. So it's got to be dividing. It's got to be dividing by 60, dividing by 60 again, dividing by 60 again, which makes 7,200, like someone put in the chat. Do you follow me? Like you do that. What's the lesson now? I'm going to move on. I know most, like even there's two types. Like half of you hate stoichiometry because you can't do it, or unit conversion, so you don't want to hear about it, and half of you totally can do it, so you don't want to hear about it. I hear you. The lesson in physics is that actually it's a lot easier to do physics when you make the assumption and the belief that it is meant to make sense. It doesn't always seem that way at first, but it is meant to make sense. So when in doubt, you stand back from a problem and like literally try to make sense of it, especially when you have a simple choice, like, am I multiplying or am I dividing? Like ask yourself, do I want the number to be bigger or smaller? Like that is what physicists do. Okay, all right. Now I'm gonna look in the chat. Oh, I just got, was that like a thingy? Okay, wait, so I'm looking in the chat. Okay, cool. Someone just said, never mind, it was my math that was off. Cool. Yeah. Set 1/7,200 miles per second squared. Yes, I agree. Good. I'm looking in the chat. Fact, I agree. I messed up on that question. Oh, but the person that said I messed up figured it out. Great. Awesome. Submit for points. Would it still be correct if we put in fraction form? Yes, fraction's fine. I mean, look, what's recommended? What's recommended is decimal scientific notation. That's preferred ultimately. I mean, the goal of all of this is to like become a science researcher and communicate with or like have a job and communicate with the rest of the world. So decimals and scientific notations preferred. But am I going to take off? And for the exam, it's preferred. But yeah, but I'll say this too. Oh my God, I'm just ultimately, communicating with the rest of the world is preferred, i.e., scientific notation. But I'll tell you this too, we are physicists. So the other thing is, when in doubt, it is much more preferred to put a number that means something to you that you can relate to, not just you, like you feel like, don't put like, I feel like loving the square root of 7. Like, I don't mean like that you can relate to like that, but put a number that intuitively makes sense, or more the point that you could imagine measuring in the lab, right? So, or measuring in the real world. So that is, in fact, part of the reason why part A, we just ask, what is the miles per hour per minute? Because we can relate to that. And yes, oh my God, I can't believe so one thing in physics that makes physics different from math is scientific notation is better because we are scientists. But for example, if you're ever doing and this will happen a lot, like in this class or the next class, if you're doing something and then like you get that the answer is like square root of 2, in a math class, they have you leave it as square root of 2. right? Like radical 2, because that is exact. And it is, it's exact. But in a physics class, we would rather you say like approximate equal signs like 1.41. Even though that's not exact, you were chopping off digits, but it is a number that we could imagine seeing on a meter stick, like 1.41. So we do prefer to err on the side of numbers that could mean something in the world rather than numbers that are perfect in our heads. So it is a balancing act. So it's a fair question. But I'm gonna go on. Okay, I'm just gonna yeah, we rounded it up, so it's fine. Oh, multiplayer co-op, Maria. I think that's valid. Oh, multiplayer co-op, Charlene. Okay, I got point. Yeah, yeah, yeah. Word up, Nasreen. Awesome. Okay, this is good. This is good. And when this happens, this does not count as rabbit hole. Like if we were in the middle of a chat discussion about one answer for the rest of the semester, I'd still consider it a valid use of your time. Like really, not mine, but no, no. Okay. So, but I am gonna go on. Yeah. Oh, I literally had to ask when I was to yeah, fair enough. I forgot. I forgot that scientific notation existed for a minute. For a minute or for 1.2 hours or seconds. Okay. And like if he's casually hitting high. Thank you for noticing. No one ever thank you, direct chat person. I don't know what you mean. Okay. Uh okay. If nothing else, if one other lesson, all this stuff, unit conversion, scientific notation, SOHCAHTOA, all these kind of things, I just want to reinforce the message. When I learned all those things, I became a man. No, when I learned all those things, I even liked this stuff, right? And they didn't mean anything. I was like, really? Can we get to like something real, please? Like, I'm trying. First, I hated it because I didn't understand it and it was confusing and annoying. And then I hated it because I got it. And I was like, this is stupid and boring. Can we please move on and do something? I can relate. But I'm telling you what's crazy is that all that stuff does turn out to mean something. It does. Like, it's at whatever, like, it does. Okay. Okay. So we're gonna go. You people, you've learned. I know this class has hit its stride because you've all now learned the art of keeping me off the topic, which is not like really that advanced of an art, but an important one. All right. So, acceleration and direction. I'm gonna like yell out answers to this one. See, I did all that so I wouldn't rabbit hole, but oh well. Okay. Number 4, I'm going to try again to just yell out answers and move on to things. Right. We're looking at number 4. Audi, driving Buick, and Camry and dirt bike. So I'm going to choose. And again, if you're doing homework, you're making a diagram, all that stuff. So I'm going to choose a direction. That's part of Galileo. I'm going to say east is positive and west is negative. That's what I'm saying. Now I'm going to stay consistent with that throughout the whole thing. So, so for B, the initial and final velocity of each vehicle using positive and negative signs. Yeah. So the initial velocity is positive 10. The final velocity is positive 50. The Buick, the initial velocity is negative 10. The final velocity is negative 50. The Camry, the initial velocity is positive 50. The final velocity is positive 10. The dirt bike, the initial velocity is negative 50. The final velocity is negative 10. And when I say initial and final velocity, if you're writing it down on your piece of paper, you would say V naught equals negative 10 meters per second or whatever, and V equals negative 50 meters per second or whatever, right? You would include units in your answers and stop me if I'm going to incoherently. And initial velocity is V naught, like V sub 0, right? And final velocity is V. Textbooks and websites will sometimes say, or and high school teachers, and I'm just saying, other people will sometimes say VI and VF or V1 and V2. That is all totally fine. That's totally fine. It's totally correct. We tend not to do that. We tend to say V naught and V or X naught and X, right? Whenever, and that means the same thing. Okay, so we did A, B. Okay, so the average acceleration of each of these vehicles during the 10 seconds. Yes, this is just plug and chug, but with the emphasis here is for us to all get used to the fact that some of these answers are going to have negative signs in them. That's like what we're trying to realize here. And that the negative signs don't necessarily mean what you might have thought that they might mean. So here, excuse me. So here's my answers. And I think there's something in the chat, but well, actually, wait, there's something in the chat. Hold on. Sorry. Okay, fine. Thank you for telling me. I appreciate it. Oh, got it. Okay. So the answers for C. The answers are positive. So average acceleration, average A with a bar over it. Average acceleration equals positive 40 meters per second squared for the Audi. For the Buick, um, negative 40 meters per second squared. Yeah, sorry, I'm spacing out. Yeah. And for the Camry, sorry, for the Camry, negative 40 meters per second squared. And for the dirt bike, positive 40 meters per second squared. Those are the answers I'm looking at. Oh, I see there's something in the chat. That's maybe not surprising. Wait, did I make a mistake? Wait, I'm looking at the right chat. Wait, really good question. Okay, no, and I'm glad. So someone in direct chat saying, hold on, why do I keep saying 40? Oh, four. I'm sorry, four. No, you're absolutely right. Oh my God. Sorry. You're absolutely right. And I'm not joking, and you should submit for points for the respectfully corrected portal. Let me say that. Good thing I didn't write these down. I'm sorry. Every single time I just said 40. You're absolutely right. I meant four. I mean 40 divided by 10, which is four. You 100% correct. Four. No, I'm cooked. Thank you. And in fact, I don't want to joke about that. Sorry, that's just a tight brain fart on my part. It's four, but I don't want to confuse anybody. So please just raise your electronic hand if you just caught that got corrected. That it's the answers are all like fours, not 40. Just raise your electronic hand. Awesome. This class really does pay attention. Awesome. I see 14 hands. Oh, wow, 16 hands. Awesome. Thank you. Okay, sorry about that. And thank you for the correction. Thank you. And you should submit for points, all of you, for that. And multiplayer co-op. And the points add up. I'm not kidding. Thank you for catching that. I didn't do it on purpose, but thank you for okay. So yeah, don't cry. Dry your eye. I'm gonna cry personally now. But yeah, near heart. Yeah, no, I don't have a heart attack. Now I'm gonna have no, sorry, four. Four. Yes, okay. Don't cry. I love this class. Oh my God. I'm gonna miss you after you kill me. Okay. Lock in. Never heard that one. That's a good one. I gotta think about that. Is that like a thing? Lock in? Okay. No, you're not kill. You're gonna kill. No, I'm saying you're gonna want to kill. No, you're not kill. Well, you're kind of. I'm like, as in, I'm dead. Yes. Isn't that what the kids these days are saying? Oh, to focus. All right, nice. Okay. Um, you crazy kid. Okay. All right. So the point. Really? That's very cool. That's very cool. Okay, thank you for coming to my bar mitzvah. Okay, today I am a man. Okay, that is very cool. Um, well said. Yes. Uh, D. I'm gonna move on. Good luck. I'm gonna move on. But the summary in D, and this is important. I mean, again, maybe some of you thought about this in high school. Fine. Or maybe some of you just like accepted it and memorized it in high school. Fine then, not fine now. Which is the takeaway is acceleration does not, excuse me, acceleration can be positive or negative, right? Acceleration can be positive or negative, just like velocity can be positive or negative in one dimension. Acceleration is a vector. It has magnitude and direction. Not only can it be positive or negative, but once we go into two dimensions or three dimensions, then acceleration will have an angle as well. Like it really has direction, okay? Right now, that means it's either positive or negative. So that's true. But what's also true is negative acceleration does not necessarily mean slow down. That is a key takeaway here. If you look at those four answers, well, I guess you all got them right because you all corrected me. So I guess you get it. But just notice that there were two cases of negative acceleration, two cases of positive acceleration. And it wasn't like two slowdowns. What negative acceleration can mean losing speed while you're moving in a positive direction, or it can mean gaining speed while you're moving in a negative direction, right? And same thing, positive acceleration does not necessarily mean gaining speed. It could be losing speed while you're moving in a negative direction. And moving in a negative direction does not mean that you fail to lock in and now you're screwing up your academic. Moving in a negative direction is not a judgment. It just means moving to the left rather than the right, or the south rather than the north, or whatever, right? But we're starting to realize that like direction really matters in physics, and directions all designated by like signs which you choose at the beginning, but you stay consistent with. Okay. Yeah, it's totally relative to direction, as someone just said in the chat. Yes, someone just said in the direct chat. It is relative. Ooh, I like that. It's relative to direction, i.e., all the stuff is relative. Yes, well said. That is points right there. Okay, there's a person who doesn't even have to take an exam and is going to get it out. No, I did not say that. I mean, I said, okay, so that's that. All right. Honestly, the next one, five, I'm rabbit holing. So I overuse that expression too. But five, it's the same point. Okay. It literally is the same issue. Answer to A is 17 meters per second. B, the negative sign indicates the direction. C, if the hydrogen atom has positive acceleration, no, it is not necessarily speeding up. It could be slowing down while moving in the negative direction. Like exactly what the answer to this question. Yeah, so we just answered that. Okay, if you have any, I'm not trying to, but if you have any questions, tell me. But five, we're done. Now six gets interesting. And by interesting, I mean I think it's interesting. And certainly it's important. Number six, we're looking at now. Please, I mean, bear with me for a unit of time that I will define in retrospect after it's over. Okay. Number six. Okay, I'm going to keep talking. I know this is like instead of writing things down I guess. If you number six, it asks you to find the average of each set of numbers. And so with the expectation is that with each set of numbers, you would do what you do in a math class. You would add them all together and divide by the number of numbers. Or certainly that you could do that. And certainly that if you do that, that is one way to guarantee getting the right answer for each one of them. Adding them all up and dividing by the number of numbers. And that, as you know, that's called getting the mean average, like the arithmetic mean, right? When you add them all up and divide by the number of numbers. Okay. And I should say, yes, what it's looking for in A, it should have specified. It's not asking for the mode average. It's not asking for the median average. It's tacitly asking for the mean average. It probably should say that. So if you do that, if you add all the numbers together and divide by the number of numbers, which tends to be seven, I guess is it always seven? Yeah, I guess it's always seven. So if you add them all up and divide, no, it's not always seven, but it tends to be seven. Then you get the averages. And I think you'll find that for the first one, the average is 4. For the second one, the average is 7. Stop me when I'm wrong. For the for the third one, yeah, the average is 9. For the next one, do I need a calculator? No, I don't think I do. For the next one, I believe the average is 27. For the next one, I believe the average is 11, right? And then for the last one, I need a calculator, which is a part of the issue of the. Now, I'm not saying you thought about it this way, but for the last one, I believe the answer is. I'm so embarrassed to use a calculator in front of you. Please forgive me. Is it 20? Is that possible? I believe it is. You forgive me. Thank you. Oh, and 20. Great. Awesome. Yes. Okay. I might be forgiven. Ooh, this class, yo, comma, yo. Might be forgiven. Uh, okay. Okay. So the last one you agree is 20. Now, so you agree with my answers, it sounds like so far. Now, you notice. I mean, look, let's get to the point. Then it asks you, like, what's the deal? Like, did you notice any pattern? Did you notice? And what you notice is that I could do five of them in my head, and only on the sixth one did I need a calculator. And I mean, I like numbers and all that. Some of my best friends are numbers, but like, I'm not sitting there in my head going one plus two plus three plus four. Like, I'm not. I mean, I'm not that good. So what I was doing in my head, I'm sure you've come to realize for most of them, I was literally just looking for the middle number and asserting with confidence that it would be the average that you would find had you added all the numbers together and divided by seven, which many of us would do for most of them until we start noticing that pattern that, wait a minute, can I just like pluck out the middle number? Like, and the answer is yes to a point, but even to the point where even in number five, you could pluck out the middle number, even though you don't even see the middle number, even though it's not one of the numbers listed, right? Like the answer to five, tell me if I'm wrong, and I'm serious. Like maybe I'm making a mistake somewhere, but in number, or if you missed something, since I'm just talking, but in number five, the answer is 11, even though I don't even see the number 11 there, but it is the middle number. Right. And I think it's right. So I can get away with just plucking the middle number every time, except for number six. I mean, except for list number six. So something is going on. There's some condition that allows me to pick the middle number, but I have to meet that condition in order to pick the middle number. Yes, no. Oh, okay. Oh, wait. Awesome. If you can call me Brooke, can I call you sis? No, I'm not gonna. What am but yeah, wait, no, but there's like something very. No, I can. Ooh, I feel like I just went up in the world, and I'm not even being sarcastic. But wait, okay, and I totally want to. Wait, there's like serious things happening in the chat. Okay, no. Oh my God, no, there's something very good happening in the chat with the bra person. Um, because they're even ahead of me and thinking that they're behind. They're thinking they did something wrong, but they're actually ahead of me. Um, one sec. I'm just like social promotion. Yes. Hold on. That's funny. Okay, good. Wait. No. The pattern you picked is right. Hang on. All right. I'm gonna switch screen. Wait. So this is important. This is a homework problem, right? So like obviously it was like this is not a random tangent. There's a very important purpose to this homework problem that is actually subtle, has a couple of, so I'm going to switch screens and so I can start writing this down. And the person who's in the direct chat right now, no, you did not do a different pattern or a wrong thing. You are just saying a more sophisticated version of what I'm beginning to, I'm not kidding. You're ahead of it. You'll see. You do get it, direct chat person. Uh, okay, what I'm saying in English to everybody right now is it seems like, number one, all of you, we're about to make an equation out of this, and it's actually our first, it's our first double equal sign equation that we have. It's our first equation that we're about to get that is not just a simple definition. It's our first equation that's actually like an observation or a discovery. So so it's not a small deal. So I'm going to switch boards, obviously, in a sec, or screens. But the first thing I'm saying that I think most people did notice is at some level, for many of these lists, it seems like if you're being asked to calculate the mean, you could somehow get away with just plucking out the median, right? It seems like, and that's still the person who thinks that that's not what they did. It still doesn't contradict you. You'll see in a second. But so far, it seems in rough English, like with some of these lists, when you're being asked to get the mean, to add them all up and divide by seven, you somehow could get away with just inspecting the median. And it seems like they're one and the same for most of the lists. But as direct chat person said, it only works for the lists where there is a constant change, right? Where the numbers are increasing or decreasing by a steady amount, right? That's the key. Yeah, like assuming you put the numbers in order in your mind, like even in five, where it's like tricky, like presents the numbers in some way that's not in order, but it's just a list. So if you ordered them in your mind, you would see that all those numbers are always increasing by two, right? As long as all the numbers are increasing or decreasing by a steady amount, literally a steady amount, then somehow this trick seems to work. And I'm going to switch screens, but I literally mean a steady amount, like not just a pattern. Not just any old pattern, because even that last list is definitely a pattern and definitely relates to like lab number 3 in a big way. It's but it's not a steady increase, right? So I'm going to switch screens and try to put this into an equation form. But also, I'm sorry, I just realized there was something in the chat a long time ago that I noticed and was going to get back to, and then I may still not be able to, but I want to acknowledge, because there was a really, sorry, before I move on, I just remembered that there was a question in the chat, hold on, about, like, it was like a general question which seemed important. Hold on one second. Yeah, can I explain? Someone asked me, I just want to acknowledge, like over a half hour ago, someone asked me, and I apologize, can you explain how constant acceleration is vertical and constant velocity is horizontal? We did lab 4 on this, and I'm a bit confused. Okay, wait. A, it's a great question. B, I really, I want to just reward or encourage, reinforce that anytime any of you raise a question here about what's going on in the lab, that is a good thing. Sometimes I may not be able to get too involved in it, like maybe right now, but the more all of us, me and you, can make sure that the material from lecture is communicating with the material from lab, that is a good thing. They're definitely meant to be linked. And they're not always going to be, sometimes one's going to be like sort of annoyingly ahead of the other or behind the other, but it's definitely one class. So I'm glad anytime you can tell me where you are in lab and I can help with lab reports and stuff, that is on bounds, in bounds. Okay, so great question. Now, I'll give a quick answer to that, but I can't, like, it's true, like I'm all over the place, right? But what we're about to see, if I move on, is that there's some property of Earth. It seems like we've noticed for hundreds of years that things fall toward the center of the Earth automatically. Like the center of the Earth seems to pull objects toward it, right? I mean, I'm not being sarcastic. Like we all just like notice that. In lab 3, and I'll get to this more explicitly in a second. In lab 3, one of the big takeaways of lab 3 is that when things fall to the ground, when they free fall, when they're thrown or thrust or grabbed, but like when things just naturally gravitationally fall toward the surface of the Earth, what you're supposed to be noticing in lab 3. Wait, I think my son is about to have it. Oh, my son is homesick. Pardon me. No, maybe not. All right. Oh, yeah. Hold on one second. Sorry. All right. Yes. Okay. Is it also on? It's Roblox. Okay. And you know how to do, like, all right. Very tricky to ask me in the middle of it, but yes. Okay. Yes. Thank you. All right. Oh my God. Okay. He's so smart. He knows if he asks me in the middle of class, what's the chance I'm going to like get into an argument about it? He just totally asked if he could join a Discord server regarding a Roblox game, and he's 10. And I'm all for it because at least it's not, my entire parenting philosophy is as long as it's not Fortnite, which is not to say that he plays Fortnite all the time, but like anything he asks for that isn't Fortnite, I'm like, yes, maybe that's 1 minute less of Fortnite a day. Okay, sorry, that's my parenting philosophy. Okay, and I don't get me wrong, Fortnite's very cool. I'm not saying that, and this is not a paid advertisement. I'm just saying like, oh, um, okay. Uh, um, um, Things when they fall to the center of the Earth, what you're finding out in lab 3. Now, again, I know I'm a little bit off the thing here, but this is all about acceleration. So what you're finding out in lab 3 is that when things fall, of course they move, like duh, they're moving toward it. So of course they have velocity. But what you're finding out in lab 3 is that they're not just velocitizing, they're accelerating, right? you've heard that your whole life, but like that's not odd. Just because something's moving doesn't mean it's speeding up or slowing down. But in lab three, you're finding out that it's changing its position. So there's a velocity. It's changing, but it's changing its velocity. So there's an acceleration. But the other thing you're finding out in lab three, and I'm going to get to this more in the homework in a few, but the other major insight, even though it seems really weird because it's like bolts and a string and all of this, what the takeaway of lab three is supposed to be is, yeah, there's a change in velocity, thus there's an acceleration, but there ain't no change in the acceleration. The key insight of lab three is that when things free fall, they accelerate. Oh, watch how I'm going to do this. This is going to totally tie back to this homework problem now. When things fall toward the surface of the earth, naturally, when they free fall, they accelerate at a constant rate. That is the takeaway. And now, how that's the takeaway of lab three, maybe is another discussion. It doesn't seem, I know you feel like you're just like tying bolts to strings and blah, blah, blah. But I'll get to this in a few minutes or days, that what you're seeing in lab three is that there is a change in velocity called acceleration, but there is not a change in acceleration. The acceleration is constant. The change is unchanging. That is an insight. That's what you're learning from lab three. Now, first of all, you may already have known from high school or whatever, 9.8, 9.8, 9.8. I'm not, don't get me wrong. Some of my best friends are 9.8. Like, yes, that number is important. And yes, it's true and all that. But we get so caught up in that number in high school or whatever. And I'm not making fun of high school, but I'm just saying, like, when we're first looking at these things, sometimes we get so caught up in the number 9.8 that we don't see that the real issue of the number is that it's a number. It doesn't matter whether it's 9.8. Frankly, if you were measuring in feet per second squared, it'd be 32 or whatever. Like, it doesn't matter what the number is. It matters that the number doesn't seem to be changing. It seems that when you drop things, they gain speed in a constant way, much like the lists in this problem here. So back to the person's question. From here on in, that means in the vertical axis toward the center of the earth, from here on in physics, yes, along the y-axis, we can always assume that there is an acceleration occurring, but not changing, i.e. there's a constant value of acceleration, which, okay, turns out to be like 9.81 meters per second squared. And like, you're allowed to use that from now on as of lab three or as of whatever. So yes, in lab four, in this direction, you should assume that there's no constant velocity, the ballistic projectile that falls. You should assume that there's no constant velocity in the y direction. You should assume that there's a constant acceleration or a steady speed up rate of 9.8 meters per second every second. However, in this direction, in the horizontal direction, there's no gravity. I've never experienced that things automatically want to move to the left or the right or the north or the south, right? I'm not being sarcastic. Things seem to automatically want to fall down, i.e. if I hold them at speed 0 and let them go, next thing I know, they're at speed something else. They automatically accelerate. Yeah, but that doesn't happen horizontally. Horizontally, Galileo's principle of relativity governs. Horizontally, things are just at whatever speed according to the observer, and they just maintain that speed unless the observer changes the observer's speed. So I don't know if that was a little bit of I don't know if that helped. I'm just proud of the person who asked the question about lab. I think it's good to do that. That's my answer for the moment. But to bring it back to the homework, what I'm saying is it's possible for things to change in an unchanging way. And that's really where this curricular ship is headed. We are now looking at changes that we're looking at constant acceleration. And the model for it is lists 1 through 5. Imagine, and I swear I'm going to switch boards in a second and turn this into an equation or try. But like imagine that each one of those lists are not just random numbers. Imagine that they are instantaneous velocities, right? And so that and each number is occurring at some like next second of time or minute or hour or whatever, right? So like in the first list would be like 1 mile, 1 meter per second, and then the next second 2 meters per second, and then three. Then those velocities are changing, but in an unchanging way. That is called That's called constant acceleration. Lists 1 through 5 are constant acceleration, whereas list 6 is not. It's something, but it's not that, right? So I'm gonna switch boards, I swear, but there's like the chat lights are going crazy. Hold on a second. Somebody get on the Discord server and the Twitch server and talk to Destiny. Did I say Destiny? Yeah, he's so good. Okay. Wait. Destiny is your brother? Oh no. Okay. Got it. Wait. Oh, okay. I'm looking at the chat. Sorry. Wait. And I swear the person who thinks they chose a different pattern, I swear I'm going to get to that, and it's not a different pattern. It's the correct. Um. Oh yeah. Colin in everyone. I believe it is because a projectile does not accelerate in the horizontal. Yeah. Like I agree with Colin. I agree with Colin. I guess I'll leave it at that. Yeah. I mean, and he's using the word force. Like, of course, I agree with him. I mean, we haven't like used the word force yet, but yeah. But if force just means like some kind of influence or push or pull or whatever, right? When things go in a horizontal direction, they no matter how hard you throw them, once you throw them, they're thrown, and then nothing's touching them anymore. Nothing is influencing them. There's no magnet or something like that. So in a horizontal direction, you can accept it as a truism. In the horizontal axis, there just is no acceleration unless like literally someone's doing something. But in the vertical, there is. So yeah, I agree with Colin basically. Okay. Not bro playing Roblox. Okay. I'd be playing Roblox at 20 on the weekends. Yeah, oh yeah. I mean, Roblox is a it was a major, okay, so I'm switching the screen. Yes, it was a major step forward in my life and in my parenting when I realized, when I heard myself talking to another parent one, and they're like, blah, 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 but is Roblox really a good game? Or blah, blah, blah. Is Roblox, I mean, an okay game for blah? And just out of my mouth, like I was such a jerk. I'm like, Roblox is not a game, it is a platform. And the minute you realize that, the discussion could take a different direction or something. And I was like, did I just say that? But it's true, right? Okay, not a paid advertisement. Okay, let's switch screens. And yes, maybe platform isn't even the right word, but you know what I'm saying. Okay, sure. Actually, Skrillex once said that about like that type of music, which I forget what it's called, but like he was being interviewed and they're like, well, what about this with this genre of music you play? And he's like, it's not a genre, it's a platform. I was like, whoa, dude. Okay. Okay. Parkour. Okay. Okay. Is this okay? Um, Okay. First thing in English, I'm saying, and now here we go with finally, I'm going to turn it into an equation. I'm going to show how the person in the chat who kind of maybe thinks that they is like wrong. I'm going to show how they is right. Um, but first of all, in English, I'm saying, and again, I know I'm going back and forth between like jokes and not jokes, but like this is a serious part. So definitely stop me if you don't like it or understand or whatever, or tell me to go on if it's already clear. But the numbers, if you look at those numbers, if you imagine them being instantaneous velocities, then you can see intuitively that when they're changing by a constant amount, when the acceleration is constant, then in order to get the mean, the average velocity, you actually could just inspect and pick out the median velocity right now. Now, here's an argument. Like it seems that way just from looking at it, but it actually is logical. It actually has to be that way if you really think about it, because, and this is an if and only if kind of situation, because if the numbers are increasing by a constant amount or decreasing by a constant amount, then the amount that you gain above the middle must be the same as the amount you lose below the middle, right? Like the if you're looking for an average, the I can't say it any better than that. Well, yes, I can. I can say it the way that the direct chat person put it. Like it's so true that the middle number, the median, has to be the mean, which is not always true in life, but it is true if there's constant acceleration. It has to be, because if you really think about it, what you could do in any one of those lists, this is the part that the person in the direct chat said. You could just take the very lowest number and the very highest number and add them together and divide by 2, and you would have the middle number, which is also the mean number, right? Because like someone in the direct chat said that they were doing this and then they thought it was like a different thing. No, it is the thing. Someone in the direct chat, and it's awesome. Someone in the direct chat said, I just took the lowest. And so, for example, with the list that goes, for the list that goes 1, 2, 3, 4, 5, 6, 7, they were just like 1 plus 7 equals 8, divided by 2 is 4. Boom. And yeah, that's right. Because what they're in effect saying is I can ignore the 2 and the 3 and the 5 and the, because I can ignore the 2 because it takes me away from the middle. It takes me away from 4, like by 2. Like 2 is like 2 less than 4. So 2 would take the middle away lower by 2. But 6 takes the middle up by 2, right? Each one of the intervening, if as long as everything is increasing or decreasing by a constant amount, then all the intervening values are always necessarily counterbalanced by one on the other side of the middle. Like they're evenly distributed around the middle if the acceleration is constant. So what that literally means, what the direct chat person is saying is, this is we can say in equation form, if and only if, IFF means if and only if acceleration is constant, you see what I'm right? If acceleration at any moment in time is the same value as it was at the beginning of time of the experiment, right? And for now, that's the way I'm going to write constant. The way I'm going to say a value is constant is I'm going to say it equals to its initial value. So if and only if acceleration is equal to its is constant, then the average velocity will be equal, double equal sign, will be equal to V naught plus V over 2. That's what the person in direct chat is saying. That's the part I didn't say until just now. Like literally what the person in direct, and that is an equation. So like, I don't want to keep dwelling on it, but basically one of you just discovered an equation on your own. And I mean that. I don't mean you're the first person in history to discover the equation. If I had a Nobel Prize in my pocket, I would I would keep it and like move to Tahiti, but I would give it to you. But what I'm not saying you're the first person ever, but I am saying, look, someone in the room just in English came up with an equation, which really shows you not only that they're smart and cool and all of that, but also shows you none of these equations are formulas. They're not just like out of nowhere things that no, they're just English recognitions that we make, and then we like express in an efficient way. So what we're saying is if velocities are changing by a constant amount, then one second. Hold on. we're literally saying if acceleration is constant, then the average velocity for the whole thing is the instantaneous velocity at the middle of the time. And that the instantaneous velocity at the middle of the time could be computed, could be calculated by simply averaging the smallest and the largest instantaneous velocities, like adding them together and dividing by two. This is very big deal, right? And again, that's what the person in direct chat's saying. I'm saying this is our third equation, technically our fifth equation now, but it's our first equation that has a double equal sign in it. Let's be very careful. Oh, sorry. The definition of average velocity is displacement per time. That's the definition. Triple equal sign. We didn't discover it. We can't undiscover it. It's just like a language construct. Average velocity means total displacement over total time. Therefore, if it's ever correct, it's always correct. It's not always useful, but it's always correct. And it frequently is useful. Well, someone's here, right? So we spent a lot of time at the beginning of homework saying what average velocity is that displacement over time. And we even had a couple of problems. Like Hill figure and Grandma Grimm, right? Where we were like, don't think that to get the average velocity, you could just like average velocities. Don't just take 40 and 60 and add them together and divide by two and get 50. No, 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 you bad person. You don't do that, right? And I'm not taking, I mean, we didn't say bad person, but like we did that, right? Now we're saying, okay, but you know what? Under certain conditions, now that we've learned there's a difference between average velocity and instantaneous velocity, and that's the other thing. We're making a big deal back then, like there's average velocity. Average velocity doesn't tell you what you're doing at a moment, it tells you what you're doing on average. And then we get into how do we know what we're doing at a moment? Well, that's a whole calculus class, but we do. It's called a derivative, right? Now we're saying and then we learn about like instantaneous velocities changing, and we call that acceleration. Now we're saying if the change occurs in an unchanging way, if the velocities are changing, but the rate of change doesn't have a change, if there is a second derivative, but no third derivative, that's what we're saying, right? Then we're saying, oh, you know what? Actually, then in order to get average velocity, you can just average velocities. You could literally just average the lowest with the highest, add them together, divide by two, and that will take care of the entire range of numbers, and it will give you the instantaneous velocity. It will give you an instantaneous velocity. It won't just give you it will give you how fast you're going at a particular moment. What moment? The middle moment, the middle of the time. That's a big insight. First of all, it means that sometimes we can average velocities to get average velocity, even though I made a big point of saying don't assume that you can. You should not assume, but sometimes you can. Here's when the sometimes. And then second of all, and please write this some, I'll write it. The other, because I know we're almost done, but there's the other insight here. I will move on, but the reason I'm like, first of all, I think this is a discovery, and I think it's an interesting discovery, but it's also subtle because with this one, this is like a GDP now. Like when we're doing problems in the future, kinematic problems, often if you don't know what once you've set it up and you're trying to answer a question and you don't know what your step three GDP is, it's often this equation. And often, like other subtleties, it might not occur to you to even think that it's relevant because it's not obvious that because this one can be plugged into, it can be used for plugging and chugging, but it's not always used that way. Sometimes the purpose of this equation is to remind us that if we have the average for the whole, we actually do have one specific value at a specific moment, the moment being in the middle. And so this allows us to sort of convert our knowledge from averages to instantaneous. And that's frequently exactly what we need in physics. Like we just know the average, but we want to know how fast is it going, like right here. This allows us to know how fast it's going right here at the middle. And then we can use an acceleration equation to like predict, to work backwards or forwards and figure out how fast something's going at some other moment. So this is important. And again, I commend like all of you for being so and involved in this. And the lab question, I think, actually helps. I think it does. And the person in direct chat, I think, did get it. I'm going to pause for it. So this is a new equation now. Technically, we have five. Oh, yeah, totally. No, period. That person is a researcher. No, I'm very proud of that. I'm not even going to joke or about that. So technically now is three. Let me just look at where we are in the homework. Well, at least okay, that puts to bed homework 4. That's good. So we're almost caught up with ourselves, and we have class tomorrow, so we can do homework 5. Well, so we're actually strangely, wait, is big old and right now, because you're all being so good, and because I see where we are in the class now, we have 3 minutes, but right now, there was a homework due 2 days ago, which I now can start to get to, but then there was the next homework was due, would have been due a week from 2 days ago, March 10th. I'm going to extend it right now so that because we're so close to me catching up with you that you deserve a little more time and we could use it. So I'm right now, Big Old Duck was going to be due Monday. I'm going to change it. Well, I'll change it to Wednesday. Maybe that's not a huge deal in your life, but I'm doing it. But you can remind me when we have class on Monday, you absolutely can remind me again, say, are we ready for Big Old Duck? It is a long assignment, actually. Wait. Hold on. Well, I'm making it Wednesday for now, but you could check in with me again, or you could check in tomorrow and say, do we really have enough time for that? And I'll rethink it. Let me just see. Yeah, the homeworks start getting sort of bigger and harder from here. So, all right, I'm going to leave it. So, anyway, the next homework is due a week from today now. Okay, not a week from 2 days ago. Hopefully, that gives you a little more time. Um, and we still have 2 minutes. Hold on, I'm looking at the chat. Sounds good. Okay, thank you. And yes, so we'll get Mercy is appreciated. Okay, but yes, yes, we have class tomorrow. I mean, tomorrow is Wednesday at John Jay. So we have class at this time for good or for bad. Yes, unless you hear otherwise. We have 2 minutes left. What I'm just going to do with the 2 minutes. I'm not going to start a new sheet or anything like that. Here's a quick. I'm just going to summarize the equations we have right now. It might help some people. Like as far as I know, so anything I write right here, right now, could be used as a step 3 GDP when you're solving a problem. Plus Galileo's principle could be used as a GDP. But here's the equations. Okay, literally, this is a cheat sheet for the class right now, as of this moment. I mean, it's not cheating, but you know what I'm saying? And it's sort of and that's class. So that's what we know so far. That's what's like legal to use to solve any problem. And if you see the patterns in this or you understand, then you like know stuff. So awesome. I really like this class. I appreciate it. So yes, I will see you tomorrow at 10:50 Don't do any new homework unless you need. Yay. Okay. Okay. Awesome. Thank you. And I'm ending, or I mean, I'm turning off the, yes, have a good day.